So last time actually dia kata the space between the young double slit, okay, and then it's then filled with water. Explain what will happen to the interference pattern on the screen. The key idea here is that what will happen to the wavelength when it is actually moving inside the water. Anyone? Does the wavelength increase or decrease?
Wavelength decrease.
Decrease, okay. So logically, the wavelength will decrease. So by what factor? Actually, it comes from the formula. Lambda n is equals to lambda divided by n. So a wave that is traveling inside a medium, then you just have to divide with the refractive index. So if it is travel in air, this one becomes 1. Okay, so lambda n is basically the new lambda lah. So in this case, since it is filled with water, you can expect that the n here now becomes 1.33. So any number that's bigger than 1 will result in lambda decreasing. Okay, so here you can say that lambda decrease from the equation of lambda n equals to lambda over n when it is filled with water. Okay, now what can you say about interference pattern? Because the question want to state, describe what will happen to the interference pattern. So if you want to answer, if you want to explain, you have to explain based on from the formula itself. Okay, so here you can say delta y, or from the formula, delta y is equals to lambda d over d. So if the question asks you to describe about the pattern, you have to use this formula to describe. You don't use ym equals to m lambda d over d or m plus half. You use this one. Okay, from here, what can you say about lambda and delta y? What is the relation between delta y and lambda?
Directly proportional.
Directly proportional, very good. Okay, so if it is directly proportional, you can say that if lambda decrease, therefore delta y will decrease. So if delta y decrease, actually what it means is that pattern becomes narrower. Okay, you know that delta y is actually measurement of the distance between the next consecutive bright or dark fringes, right? So if the distance becomes smaller, then you expect that the distance becomes narrower. So the pattern will be narrower. Okay, understand or not?
Yes, sir.
Okay, so for today, one of the equation that you will be using is this one. Okay, later on we will continue lah. Yeah, that lambda n is equals to lambda over n2. Okay, so today we will learn about 8.4. Is it 8.4? If I'm not mistaken. So interference of reflected light in thin films. Okay, this one is a soap bubble. What can you say about this soap bubble? What's your observation on this soap bubble? What can you see on this soap bubble?
Reflection.
Reflection, right? And then you can see as if you have a rainbow. Punya betul? Phenomenon. So basically, light between reflected and then it will produce interference, constructive and destructive interference. Okay, later on we'll discuss about this later. So if you imagine a soap bubble, so basically this is the soap bubble, right? So you imagine yang dekat air tu kan. So basically you have thin layer of water. Okay, yang water ni or the soap maybe n is equals to 1.33 maybe. So inside here, what's the value for n? Inside here contains apa?
Air.
is air. So n equals to
1.
1. Very good. So outside here, n equals to
1.
1 as well. Okay. So here, in this chapter, we discuss or we focus specifically on this part, a very small part here. Like this one. Okay. So we draw two lines. That, okay, where this one, the middle part tu, is actually your thin layer tu. In this case, it's a thin layer of soap bubble, so 1.33. Okay, atas dia is air, below there, inside there is actually air as well. Okay. So most of the time you will represent your diagram with this pattern. You understand lah?
Yes, sir.
Okay, so we try to discuss in phase interference first. Okay, the formation of interference. So maybe we discuss something else. This is not a soap bubble, maybe a coating on lens. Okay, if you have a lens like a glasses, macam spek kamu tu, kalau kamu perasan lah, if you go, siapa yang pakai spek dia tahulah, kalau kamu beli spek, sometimes they will ask you whether you want the lens with the blue coating on or not, and something like that. So what happens is that they actually coat the lens. Okay. So on top of the lens, they coat it. So in this case, yang coating tu is your thin layer. So n tu maybe equals to 1.4, contohnya. Okay. So your N1 is basically air yang atas sini lah. Okay. And then N3 is basically your lens. The lens is glass, so normally it's around 1.5 something. Okay, so far kamu understand or not about my diagram just now? Then this one.
Faham, sir?
Okay.
Faham, sir.
So basically, if light coming in this direction, katakan ada lights, incident light towards the surface, what will happen is that part of the light will be reflected, okay, and part of the light will be refracted. So you got two parts, huh? So we want to focus on the reflected part first. This one. The first reflected ray is what we call ray 1. Okay, ray 1 here, actually the light travels, yang reflected kan, actually it seems like it travels from the denser to less dense punya medium. So if that happens, it will undergo a phase difference or phase change. So you can say that this one undergoes phase change of pi radian. Okay, so in reality, actually, because it is actually travel from denser to less dense punya medium. Okay, but the easiest way to memorize, if N1 is smaller than N2, then you have a phase change. Okay, so far, are you guys okay?
Okay, sir.
Okay, so we want to discuss about the next ray lah. So like I told before, part of this ray will be refracted and then it goes to the second surface there. And then it will reflect as well over here from the second surface. Ray 2. Okay, for ray 2, do you think that it will undergo phase different or not? Phase change or not? Dia pergi ke medium dia berubah kan? Daripada, kalau ikut reflected ni, dia daripada denser to less dense, so you will expect to have phase change as well. Okay, but at the same time, over here is the thickness of the coating. Okay, we label this one as T, thickness. because the light actually travel in and then out, so you can see that actually the light, the ray 2 travel at extra distance of 2t. So you can add lah. And travel at extra distance of 2t. Okay. So basically, the first ray undergoes phase change, the second ray undergoes phase change. Okay, if you want to describe macam kawat kaki tu kan, so basically supposedly kiri kanan bila dekat sini dia change dia punya kiri kanan tu. Yang dekat sini pun change juga. So basically bila dua-dua berubah, so basically automatic dia jadi sama balik. Okay. So because of this, okay, like I told you before kan, in phase and anti phase tu determine by the punya yang starting ni whether it's in phase or not. So in this case, because both of these changes, you can say that this one is in phase interference. Okay, can you guys follow?
Yes, sir.
Okay, because this one is in phase, we still have constructive and destructive interference. Masih ada constructive and destructive. So for constructive, the formula would be 2nt equals to m lambda. M dia tu exactly macam yang double slit lah. Kalau dia destructive, this one becomes 2nt equals to m plus half lambda. Okay. You can see that this one m plus half ni macam yang double slit, because yang double slit is actually in phase interference as well. Okay, then actually this one and here comes from this part. Okay, they actually adalah lambda over n. And then I bring the n over there, so the question becomes like this. Okay, this one you have to state when the question asks you to describe the formation of interference. If they didn't ask, you can straight away calculate. So, jadi saya tunjuk cara mudahnya. Okay, any question for in phase interference?
Sir, yang
Yes.
konstruktif tu bukan M plus half tu?
Bukan. So, ini adalah in phase, so dia adalah m saja.
Oh, dia terbalik lah. Okay.
Okay, so basically dia follows macam apa tu? Yang double slit lah. Kalau kamu ingat yang dulu saya ada tunjukkan yang pasal yang Maggie tu kan, path different tu, kalau dia in phase, dia konstruktif, dia hanya M. Kalau destructive, dia adalah M plus half. So we try to look at anti-phase first. Okay, different interference maybe we can describe with the soap bubble just now. If you guys still remember soap bubble tu, and yang kat tengah ni adalah 1.33 ataupun bubbles lah, kalau dia kasih lain, kita pakai yang tu lah. And 1 tu adalah air, and 3 is air as well. Okay, and then the thickness is 5. And then basically incident ray it comes in the same direction macam yang tadi. Part of it will be reflected, part of it masuk dalam, and then reflected as well. Okay, so you have ray 1 and ray 2. Okay, for ray 1, do you think that it undergoes phase change or not?
Yes, sir.
Yes, because basically the easiest way to look at it, if it goes from smaller number to bigger number, then you have phase change. How about ray 2?
Yes, also.
Sure. Okay, the second one, if you see, sorry, yang ni bukan 3 this one says that this. No wonder kamu cakap. Yes, okay. This one sebenarnya dalam tu adalah air. So 1 lah. Okay, if this one, if like this,
Berubah juga.
no, because this one actually dia daripada bigger ke smaller number. Dia memang tak akan travel same number lah. Kalau same number tu maksudnya dia medium. So it's either daripada smaller to bigger, and then ada phase change, Kalau yang nombor dia macam ni, dia tak ada phase change. Yang nombor dia menurun, tak ada phase change. Does not undergoes phase change. Okay. But it still travel at extra distance of 2t. And travel okay. So because of this, you can see that this one undergoes phase change, another one does not undergo phase change. So initially it's basically the same line, okay? Just that one undergoes phase change and then the one does not. So maybe they get it macam tu. Okay. So if you have a case like this one is what we call anti-phase interference because starting point itu tak sama. Okay, understand tak?
Faham.
You still have constructive and destructive, sama je. Cuma now the formula dah terbalik. Okay. So previously 2nt equals to m lambda kan. So now dia terbalik, m plus half lambda yang dekat sini. Dan ini adalah 2nt equals to m lambda. Okay. So again, if the question asks you to describe the formation, you have to state what happened with ray 1, what happened with ray 2, and then list down the constructive and destructive formula. Okay, you still have to draw as well. Okay, any questions so far?
No, sir.
Okay, if there's no question, maybe I try to make a summary on the easiest way to use the formula because sometimes they ask you to describe the formation, but most of the time they did not. So if they did not ask, so basically you don't have to write down. This one you don't have to write down, but you still have to choose the formula. So whenever you get the question, okay, the first thing that you have to do is that you have to draw 2 lines. 2 lines saja, not 3, not 1, 2 lines. Okay, and then you have to identify the middle part here. N2 tu. The middle part here will always be the coating part. Yang thin tu. So macam soap bubble, yang thin tu adalah soap dia. Kalau ada coating, like non-reflective coating, that one is your middle part, your N2. So in this case, you have to identify N2 first apa. Okay, and then you have to look, you have to imagine lah. N1 and N3 will be what? And then come list down. N1, N2, N3 tu apa? Okay, and then you label T as well. Okay, once you did that, you just have to look at the numbers that you list down. So if the numbers here, let's say N1, N2, N3 is in sequence, whether it's going up or going down. Contohnya, kalau yang ni adalah 1, 2, 3.3, this one is in sequence. Okay. Or 4, 3.2, 2.2, this one is in sequence. Okay, menurun ke naik tak kisahlah. As long as in sequence, so we identify this one as in phase interference. Okay. If the numbers are not in sequence, okay. Example, soap bubble just now, you have 1, 1.33, and then 1 kan? So they're not in sequence. So that one we consider as antiphase. Okay. And then once you identify it's in phase or antiphase, straight away you list down the formula for constructive and destructive. List down here. Saya kat sini. Constructive and destructive. Okay. So kalau in phase, there will be 2nt equals to m lambda. Destructive 2nt equals to m plus half lambda. The same goes over here, dia terbalik dengan antiphase. So this one become 2nt equals to m plus half. So be 2nt equals to m lambda. Okay, this formula are given, but they didn't say this one is for in phase ke, antiphase ke, constructive ke, dia tak cakap. So you have to choose it yourself. So the trickiest part is to choose the right formula lah. So once you choose the formula, obviously you have to substitute all the values here. Okay, most of the time, okay, unless it's specifically stated otherwise, the m will be the minimum number. Okay, main giveaway is that you want to find the thickness, the minimum thickness. So basically for this formula, okay, if you want to find the minimum thickness, basically you want to have the smallest numbers over here. So m will be the smallest number. The smallest number for m for this equation, you cannot substitute m equals to 0. Okay, if you substitute m something like 0, then everything here becomes 0. It doesn't make sense, lah. Thickness is something like 0, right? So instead, you have to substitute 1. Okay, but if the equation is m plus half, the minimum m would be equals to 0. Understand or not? Because you can substitute 0, you substitute 0.
Yes, sir, faham.
Okay, let's say it goes over here lah. If the equation is m plus half, you can substitute 0. If the equation is m lambda, you have to substitute 1. Because that one will be the minimum. Okay, sometimes they want you to find like another keyword is like the brightest reflected light. Okay, itu pun m minimum. The lowest numbers of order. Kalau dikata yang lain, you have to masukkanlah, contoh kata for order, fourth order of interference, and then you have to substitute 4. Jarang lah. Most of the time, m ni will be the minimum number. Okay. Now let's try to look at questions. I just try to remember if there anything is on. Okay, one more thing about n. N here, if you got confused which n you want to substitute, because you have 3n, right? So you use the n that you have t here. So this is your t, so your n that you need to substitute is this n. And itulah basically the quoting part, the main part that you described just now. Okay, let's try to look at question number 10. This one is from the tutorial. It says that a soap bubble is floating in air. If the thickness of the bubble wall is 100 nanometer, what is the wavelength of the visible light that is most strongly reflected? Okay, what is the first thing that you guys need to do once you get the question? Dapat soalan buat apa?
Lukis dua line.
Berapa line? Yes, lukis 2 line. That's the first thing. And then kamu tengok balik, kamu just label dia T, and then N1, N2, and N3. Label je. Okay. After that, you identify. The first thing yang kamu identify is N2. Okay. N2 ni adalah dia punya coating. Dia punya yang kita cerita tu lah, yang thin layer. So in this case, N2 dia sama dengan berapa?
1.42.
1.42. In this case, they only give you 1 values for n, so I think that this one is much easier lah. How about n1 and n3?
1.
1. Okay, good. So because this is the numbers, is it in sequence or not?
Not in
Not in
sequence.
sequence. So is it antiphase or in phase?
It's antiphase.
Antiphase. Okay, antiphase. And then immediately you can list down constructive and destructive formula. Okay. I always list it down first because later on you got confused. So notice that I haven't read through the question. Just straight away I list down the formula and then we can read back the questions. Constructive is 2 and t equals to m plus half lambda. And so big 2 and t equals to m lambda. Okay, so the question actually wanting to find what is the wavelength of the visible light that most strongly reflected. So can you see the lights being reflected or not?
Yes.
Yes, if you can see the reflected light, is it constructive or destructive?
Constructive.
Okay, very good. So basically we want to use this formula, constructive formula. So if you apply that formula, then you have 2 and t equals to m plus half lambda. So the question actually want you to find lambda. So 2 n is equals to what? N berapa nak pakai?
1.42.
Yes, 1.42. How about T? 100 nanometer, right? 100 times 10 negative 9. Okay, M equals to
1.
true 1. The minimum number that you can substitute. Can you substitute 0 inside this equation? Yes, because you can substitute 0, you substitute 0. Okay? Ingat macam tu je lah. That's the easiest way to remember. So now you should have 2 times 1.42 times 100. 100 nanometer divided by half. How much you get? Let's try to calculate.
Five 5.68.
Okay, good. 5.68 times 10 negative 7. So obviously you can change to negative 9 and then you can write down in nanometer, but I suggest you to just leave it as it is. Okay, so if you try to do something else, maybe you got it wrong and then everything becomes messed up. Okay, anyway, any question for this question?
So yang tadi saya kata M tak boleh kosong. So
It depends. Okay, like this, sugar. So you have to refer to the equation. If it is M plus half, the minimum number you can substitute is 0. If it is M, you cannot substitute 0. If you substitute M equals to 0, then this one becomes 0. So for this equation and this equation, M minimum is equals to 1. Okay, but if the equation has half like this, you can substitute 0. Okay, if you substitute 0, you still become half kan. So this one pun sama. So for yang ada half tu, M2 equals to 0. Untuk yang tak ada half, M equals to 1. Understand?
yes, faham.
Okay, right. Okay, let's try to look at next question, question number 11. Non-reflective coating of magnesium fluoride. N equals to 1.38, cover the glass, N equals to 1.52 of camera lens, assuming that the coating prevents refraction of yellow-green light, lambda equals to 565, determine the minimum thickness of the coating. Okay, first thing first, apa yang kamu kena buat?
Lukis dua line.
Yes, lukis dua line. And then, kamu label kan? T dia. And satu. Oops. And dua. And tiga. Okay, determine and 2 first. And 2 is equals to coating dia tu berapa? The middle part itulah yang thin layer, itulah yang dia punya coating, itulah dia punya yang kita nak cerita lah. So in this case, N2 is equals to
1.38.
1.38.
okay. Dia bawah dia N3
0.52.
yes, N1
1.
Sama juga.
okay. So atas dia air kan, lepas tu coating, lepas tu lens. Macam tu lah. Boleh tak?
Boleh.
Okay, so this one, the numbers are in sequence or not in sequence?
In sequence.
So is it in phase or anti-phase?
In phase.
In phase. So in phase, we still have 2 formula, constructive and destructive. Okay. For constructive, in phase, it will be 2nt equals to m lambda. Destructive, 2nt equals to m plus half lambda. Okay, so the question says, assuming that the coating prevent reflection of this lambda, determine the minimum thickness of the coating. So you want to use constructive or destructive?
Constructive.
It says that this one want to prevent diffraction. Do you see the yellow green light or not?
Oh no.
No, right. So it is a destructive interference. So 2 anti, sebenarnya reflection tu masih berlaku, just that they cancel out each other lah. 2 anti equals to m plus half lambda. You want to use this formula. Okay. Another giveaway is actually kalau dia tak sebut yang bawah ni pun, the way they say about this one, because say that this one the main application is non-reflective coating, so you can assume that it is actually destructive. Okay, but read the rest of the questions lah. Okay, so this one they want to find T minimum, so N dia equals to berapa?
1.38.
Yes, dekat mana? Yang dekat T tu kan 1.38 equals to M dia sama dengan
0.
yes, because you can substitute 0, you substitute 0. Lambda is 565 times 10 negative 9. T minimum here will be apa ni? Half times 565 times negative 9. Okay, good. 1.02 times 10 negative 7 meter. You guys understand? Any question?